Okay, continuing. The z-score is the boundary on the horizontal axis that closes off, segments off a given area under the curve. So we have to use a table or technology to find those areas when we know a z-score. Or if we know the area, then we can reverse look it up on a table or reverse look it up with technology to find a given z-score. Right? And then choose the right side of the graph. Values separating the top 10% from the others will be on the right side. Values separating out lower percentages will be on the left side of the graph. Whenever a z-score is to the left of the mean, then it has to be negative. But areas are always positive, and probabilities are always numbers between 0 and 1. Right? So procedure for finding values from known areas or from probabilities. So this is kind of a reverse of what we've been doing, what we did in the last example. You can solve for a given x score if you know the z-score. So what you first do is you find the area, the probability that you're talking about, then find the corresponding or the probability that you're given for the problem. Then you find its z-score, and then you plug the z-score into this formula, which will give you the x-score that's associated with that same probability. Right. So the lengths of human pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. So what is the probability that a pregnancy lasts at least 300 days? Well, let's sketch a normal distribution to get our bearings. All right, so the mean is 268. Standard deviation, 15. So the probability lasts at least 300 days. Well, 300 is larger than 268, so we'll put it somewhere over here. And at least 300 days means, well, more than 300 days would be fine too. So 300 or more. So an area like that, well, we simply go to our normal distribution calculator, and if we use the standard normal, then type in the mean of 268 and a standard deviation of 15, and we're interested in pregnancies that are 300 days or longer. This is going to give us the probability that of a pregnancy being 300 days or shorter, because the default area given back is the area to the left. Areas to the left will correspond to probabilities for that number and less. So we want the area to the right. So it's going to be 1 minus this number, 0.9836. We'll round it to 1 minus 0.836. 0.8316. 0.98. 9836. So 1 minus 0.9836 is 0.0164. So the probability that a pregnancy lasts at least 300 days is 1.64. And you get, if you use the between function, same mean, same standard deviation for our problem, but then the x score on the left, and then an arbitrarily large number on the right. And there it is, 0.01644. Here's an example designing an aircraft carrier, aircraft cockpit. So when designing equipment, a common criterion is to use a design that accommodates 95% of the population. We have seen that only 46% of women satisfy the height requirement for U.S. Air Force pilots. What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women to be pilots? That is, find the 95th percentile of heights of women. So there's going to be some normal distribution that tells us the probability for given ranges of women. And it's telling us in the problem that the mean height of a woman is 63.7. And the standard deviation in heights of women is 2.9 inches. So 95% of women would be some x score here that we don't know, that segments off all the area under the curve going in the decreasing height direction, smaller heights, up to that maximum height, which cuts off 95% of the area under the curve. That will give us the height that represents the 95th percentile of women's heights. So, with technology, with StatCrunch, it's straightforward. 63.7 and 2.9. Our mean is 63.7. Standard deviation is 2.9. So go to standard and then type in the area. Well, the percentile is 95th percentile, so turn that percentile into a decimal. So that's going to be 0.95. And then hit compute and it will tell you the x score. Alright, so 68.47 is the tallest height for a woman in the 95th percentile. So a woman who's 68.47 inches tall is at the maximum height for the 95th percentile, and all women shorter than 68.47 inches are in the 95th percentile. So they're among 95% of women. Any woman taller than that would be in the 5th percentile. Well, in the 96th or 97th, 98th, 99th, etc. So 68.47. And let's make a note, this area here, 95% turns into an area of 0.95, and we found the corresponding x score was 68.47. So the question also asks, should there be a minimum required height? Possibly so, in order to reach the controls, because they can't re-engineer the aircraft until they make a new generation of aircraft. And then if they make the cockpit too small, then that precludes taller women and taller men from being in there. So they have to find the right balance. In the old days, you would have to convert your, you would go and you'd go to your table, which would be standard normal. And, well, first you would have to convert, no, excuse me. We're still looking for an area of 0.95, so you would type that in here, look it up on your chart, and then get a z-score of 1.6448. .645. And then use that to find out the x. So x minus mu is 63.7 over the standard deviation, which was 2.9. Then multiply the 2.9 over. Add the 63.7 over. And then have your x. And you would get that x is 68.47 here, if you do this arithmetic. We don't need to do that on StatCrunch, as you just saw. Requirement of a height less than 68.5 inches would allow 95% of women to be eligible as U.S. Air Force pilots. There should be a minimum height requirement so that the pilots can easily reach all controls, though, as we stated earlier. Alright, find the indicated IQ score. The graph to the right depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. Alright, so we have an area of 0.2317, and we want to find x, and mu is 100, standard deviation is 15. So z-score, look up area right. Actually, look up the z-score. Corresponding to an area to the right. Of 0.2317. Alright, so for z-score, use standard mean and 0, standard deviation of 1. And then do 1 minus If we want this area to the right and we know it's 0.2317, then we need this area to the left to get the z-score. So this area is 1 minus the area to the right. So you can just type in the arithmetic into your normal calculator. So 1 minus 0.2317, and then it will give us the z-score here. Okay, so a z-score of 0.7332. And we can use that to get our x. So 0.7332 is equal to x minus a mu of 100 over a sigma of 15. So some algebra, we can get 100 plus 15 times 0.7332. So 15 times 0.7332 plus 100. So 110.998. So about 111. Interpretation: 23.17% of adults have an IQ of 111 or greater. We can do this very quickly if we type in the mean, the standard deviation, 100 for the mean and 15 for the standard deviation, and then type in the area. So 1 minus 0.2317, and then that corresponds to the complement of this area here would be 1 minus 0.2317. It will get us the boundary. It will get us the x score. So 110.99. Alright, so if you're trying to find this area here, you can do it quickly.